Hello everyone, this is Dr. L.JETHRUTH, EMELDAMARY, Assistant Professor in Mathematics, St.Joseph College of Arts and Science, Autonomous, Cuddalore. In this video lecture, I am going to discuss about inverse Laplace transform for second BSc Mathematics for the paper Differential Equations and Laplace Transform. Today's topic is inverse Laplace transform. As we all know about Laplace transform and properties of Laplace transform. Now I'm going to define what is inverse Laplace transform. If L of f of t equal to f of s, then f of t is equal to L inverse of f of s. This is called inverse Laplace transform of f of t, where L is the Laplace operator and f of t is a continuous real value function of t for which t is strictly greater than 0, and L inverse is called inverse Laplace operator. Now we are going to see few properties of inverse Laplace transform. First property, namely we call it as linearity properties. L inverse of f1 of s plus f2 of s is equal to L inverse of f1 of s plus L inverse of f2 of s. The next one is called L inverse of k f of s is equal to k times of L inverse of f of s, where k is any constant. Second property says if L of e power at f of t is equal to f of s minus a, then L inverse of f of s minus a is e power at f of t. Same way, L of e power minus at f of t is equal to f of s plus a, then L inverse of f of s plus a is equal to e power minus at f of t. The next property is if L of f of t equal to f of s, then L inverse of s f of s is equal to d by dt of L inverse of f of s. Now we shall see some of the important problems using properties. Find inverse Laplace transform of the following. So I have taken 4 problems. So we shall see one by one. To find L inverse of s by s plus 2 the whole square. Here we are given as f of s equal to s by s plus 2 the whole square. So I want to write the numerator as in the form of s plus a, whereas the denominator s is defined in the form of s plus 2. So just adding and subtracting 2 here. The numerator s, I am just adding and subtracting 2, so that we'll get s plus 2 minus 2 divided by s plus 2 the whole square. If we take L inverse on both sides, we have e power minus 2t into L inverse of s minus 2 by s squared. Here that s plus 2 is reduced by s by property 2. Hence we have e power minus 2t L inverse of s by s squared minus 2 by s squared. By cancelling s here, we'll get L inverse of 1 by s minus L inverse of 2 by s squared. That is also equal to e power minus 2t into L inverse of 1 by s is 1 and 2 by s squared, that is 2 is constant. 2 into L inverse of 1 by s squared, that gives t. The next problem is to find L inverse of s plus 2 by s minus 2 whole power 7. Here also we just take f of s equal to s plus 2 by s minus 2 whole power 7. Here in the denominator, s is in the form of s minus 2. So I want the same s minus 2 in the numerator. For that, just I am adding and subtracting 2 here and just grouping s minus 2 as one term and the remaining term as the next term, so that the numerator becomes s minus 2 plus 4, the whole thing divided by s minus 2 whole power 7. If I take L inverse for this on both sides, then the right hand side become e power 2t L inverse of s plus 4 divided by s power 7. Again, by using property 2, we have this result. So what we have is e power 2t into L inverse of s by s power 7 plus 4 by s power 7. What I did is just we are splitting the numerator into 2 parts. Okay, s by s power 7 plus 4 by s power 7. Again, by using linearity property, we have e power 2t into L inverse of 1 by s power 6 plus L inverse of 4 by s power 7. We know that 1 by L inverse of 1 by s power n is t power n minus 1 by n minus 1 factorial. Using that formula, then the result of L inverse of 1 by s power 6 is t power 5 by 120 plus L inverse of 4 by s power 7 is t power 6 by 180. So this is the answer. The third question is to find L inverse of s by s plus 1 the whole square plus 4. Here also the term the denominator equation s plus 1 the whole square we have. So I want the same term in the numerator. So for that just I'm adding and subtracting 1 here. Hence the numerator can be written as s plus 1 minus 1 divided by s plus 1 the whole square plus 4. Then by grouping this s plus 1 minus 1 divided by s plus 1 the whole square plus 4. By taking L inverse on both sides, we have L inverse of s by s plus 1 the whole square plus 4 is equal to L inverse of s plus 1 minus 1 divided by s plus 1 the whole square plus 4. Then by using property number 2, that can be written as that is s plus 1 is reduced by s by taking e power minus t common. So what we have is e power minus t, L inverse of s minus 1 by s square plus 4. Again by using linearity property, that can be written as e power minus t L inverse of s by s square plus 4 minus L inverse of 1 by s square plus 4. Now using inverse formula, we get L inverse of s by s square plus 4 as cos 2t and L inverse of 1 by s square plus 4 as sin 2t by 2. Therefore, the answer is e power minus 2t into cos 2t minus sin 2t by 2. The next one is to find L inverse of s by s square plus 2s plus 10. Here I have taken the quadratic equation. The denominator is in the form of quadratic. So here also I am going to use the what we discussed earlier. Okay. So L inverse of s by s square plus 2s plus 10 is rewritten as L inverse of s divided by the 10 is splitted into 1 plus 9 in order to get either s plus a or s minus a format. So therefore the denominator equation s square plus 2s plus 10 is rewritten as s plus 1 the whole square plus 9. When you expand it, we'll get s square plus 2s plus 10. So in the denominator, s is in the form of s plus 1 the whole square plus 9. So the numerator also I want s plus 1 format. So for that I'm just adding and subtracting 1 here. Therefore we have L inverse of s plus 1 minus 1 divided by s plus 1 the whole square plus 9. Again by using property 2, that s plus 1 is reduced by s by taking e power minus at. Hence the above equation become e power minus t into L inverse of s by s minus 1 by s square plus 9. Again by using linearity property, we have e power minus t into L inverse of s by s square plus 9 minus 1 L inverse of 1 by s square plus 9. Therefore, using a inverse of Laplace transform formula, L inverse of s by s square plus 9 become cos 3t and L inverse of 1 by s square plus 9 is sin 3t by 3. Here I have taken two set of questions. Here I am going to use property 3 to evaluate this. The first problem is to find L inverse of s cube by s power 4 minus a power 4. That s cube, the numerator s cube is rewritten as s into s squared by s power 4 minus a power 4 in order to get the form L inverse of s f of s. So here we have L inverse of s into what is f of s here, s squared by s power 4 minus a power 4. So L inverse of s f of s is what? D by dt of L inverse of f of s. Therefore this can be written as d by dt of L inverse of s squared by s power 4 minus a power 4. Now that become d by dt of L inverse of s squared by that s power 4 minus a power 4 is in the form of s square the whole square minus a square the whole square, which is in the form a square minus b squared form. We know a square minus b squared is a plus b into a minus b. Here a is s squared and b is a squared. Therefore, the denominator expression become s squared minus a squared into s squared plus a square. This f of s alone can be written as 1 by 2 of s squared minus a squared plus s squared plus a squared divided by s squared minus a squared into s squared plus a squared. That is equal to d by dt of L inverse of 1 by 2. You can just group the term s squared minus a squared as one part, s squared plus a squared as another part. The whole thing divided by s squared minus a squared into s squared plus a squared. Then dividing the numerator by denominator, we get 1 by s squared plus a squared for as the first term and 1 by s squared minus a squared as the second term. Then by taking using linearity property, so I'm taking L inverse inside the bracket, so that we have d by dt of 1 by 2 into L inverse of 1 by s squared plus a squared plus L inverse of 1 by s squared minus a squared. So here I'm going to take differential. So this 1 by 2 is constant. You can take out from the differential. That can be written as 1 by 2 into d by dt of the first part, namely L inverse of 1 by s squared plus a squared is sin at by a, whereas the second expression is sin h at by a. Therefore, d by dt of sin at plus sin h at by a we hit. So when you take differential here, the answer is cos at. Differential of sin is cos, and differential of sin h at is cos h at by a. So already 1 by a is common here. By cancelling it, we'll get 1 by 2 into cos at plus cos h at. This is the answer. The next is to find L inverse of s by s minus 4 the whole square. Here also I'm going to use property 3. Here f of s is given as 1 by s minus 4 the whole square. That f of s is multiplied by s here. Therefore, L inverse of s by s minus 4 the whole square is written in the form d by dt of L inverse of 1 by s minus 4 the whole square. Here we are going to use property 2. That is, that s minus 4 is reduced by s by taking e power 4t here. Hence, the second thing we have is d by dt of e power 4t L inverse of 1 by s square. E power 4t is function of t and L inverse of 1 by s squared is t. So both are functions of t. Therefore, using udv formula or uv formula, so we'll get e power 4t plus 4 times of e power 4t into t. So answer is e power 4t into 1 plus 4t. So thank you for watching this video.